All right, continuing to use the quadratic formula to solve quadratic equations. Here's my quadratic equation. Before we figure out what a, b, and c are, we need to make sure our quadratic equation looks like this. Ax squared plus bx plus c is equal to 0. In other words, everything needs to be on one side of the equation equal to 0. It should be in standard form as well, which it is. Okay, so we figure out a is 3, b is what's in front of x, so it's -1, and then c is -2. Then I can go to the quadratic formula. If you don't have it handy, take a look in your notes. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm using that to plug these numbers into the quadratic formula. So then x is equal to the opposite of b. Since b is -1, the opposite of that is +1, plus or minus the square root of b squared, so that's -1 squared, minus 4 times a, which is 3, times c, which is -2, all over 2 times a. Now we simplify that. Okay, make sure that you're doing every single part correctly. If you just mess up on one part, you add or subtract incorrectly, you multiply incorrectly, it's going to goof you up on the whole problem. So 1 plus or minus the square root of -1 squared is 1. -4 times 3 is -12. And then -12 times -2 is +24. All over 2 times 3 is 6. Hopefully you're following along with me. And that's equal to 1 plus or minus the square root of 1 plus 24 is 25. Kind of lucked out again that what's underneath the radical is 25. That's a perfect square. Square root of 25 is 5. And then that's over 6. So our two solutions, 1 plus 5 is 6, divided by 6 is 1. And then 1 minus 5 is -4, divided by 6 is -2/3. Leave it as a fraction. Those are the two solutions for this quadratic equation. And then my next example, I want to solve this using the quadratic formula. Before you figure out a, b, and c, everything's not on one side of the equation equal to 0. So we need to get everything equal to 0 first. I can add 7 to each side. I can only add 7 to the -1. Those are like terms. Then we end up with -3x squared plus 5x plus 6 is equal to 0. Now that everything's equal to 0, we could figure out that a value is -3, b is 5, and then c is 6. So now I could plug those numbers into the quadratic formula. X is equal to the opposite of b, so that's -5, plus or minus the square root of b squared, so that's 5 squared, minus 4 times a, which is -3, times c, which is 6, all over 2 times a, so 2 times -3. Okay, now we need to evaluate everything underneath the radical. So it's -5 plus or minus the square root of 5 squared is 25. -4 times -3 is +12. And then 12 times 6, 72. And it's plus 72 because it's a -4 times a -3. As I mentioned, that's +12. And then +12 times 6 is 72. All over 2 times -3 is -6. So now we could add the 25 and 72 underneath the radical. 25 plus 72 is 97. So it's -5 plus or minus the square root of 97 over -6. Okay. Unlike the previous examples, what we're taking the square root of is not a perfect square. Maybe I should have written the directions. I want to round everything to the nearest 10th. So here's what I'm going to need to do. Take the square root of 97 on my calculator and then round that to the nearest 10th. It's about 9.8. So here's what we end up with. -5 plus or minus 9.8. Again, I just took that square root of 97 on my calculator all over -6. Okay, then here's what I'm going to need to evaluate, probably using my calculator as well. I'm going to write everything out so you can see it. One of the solutions should be, I'll write it in a different color as well, -5 plus 9.8, and then we divide that by -6. The other solution should be -5 minus the 9.8 because of the plus or minus symbol all over -6. So I'm just using my calculator here. You can kind of follow along with me and use your calculator as well. -5 plus 9.8, and then divide that by -6. Don't forget about the negative. Should be about -0.8 for this first solution, Your second solution is -5 minus 9.8. And then you want to divide that by -6. Should be about 2.5, 2.5. So these, should be the two solutions for that quadratic equation, specifically using the quadratic formula.